Okay, in today's lecture, I want to remove this misconception that average velocity is always initial plus final by 2. No, this is wrong in fact. Average velocity is not initial plus final by 2. Not always. This is true only if acceleration is constant. Average velocity is initial plus final by 2 only if acceleration is constant. We will prove it for constant acceleration, and I'll also take an example to show that it may not be correct if acceleration is changing. So how do we prove it? For example, if it is constant acceleration, then these equations like v equal to u plus at or s equal to ut plus half at square are applicable if the acceleration is constant. When I say acceleration is constant, neither its magnitude nor its direction must change. Now let's use the definition of average velocity. Suppose I want to find average velocity from 0 to t seconds. So the definition of average is integral velocity integrated over time by time interval. That is the definition of average. But we know velocity is u plus at. So u plus at integrated over time divided by time interval. So I go to next page. This is ut plus half at square 0 to t by t minus 0. So that comes out to be u plus half at. That comes out to be 2u plus at by 2, which I can write as u plus at by 2, which I can write as u plus v by 2. So you see, I am getting this equation only when acceleration is constant. And again, here also I am using u plus at as v, which is only true for constant acceleration. So only for constant acceleration you can write this average as v plus u by 2. Otherwise, it's not correct. Let's take an example to understand this. In one case, suppose acceleration is 2I meter per second square. Suppose initial velocity is let us say 3I meters per second, and after some time, of course, the velocity is going to be, let us say, 7I meters per second. That is after 2 seconds. This is a case of constant acceleration. How did I get v here? I got v by applying u plus at. U is 3I, a is 2I into 2, which is 7I meters per second. Now, in this case, if I calculate the average velocity, I can calculate average velocity like this. At any moment, the velocity is given by u plus at, which is u plus 2I into t, right? That is 3 plus 2t into I. This is velocity at any moment. Initial velocity is 0. This is velocity at time t. So average velocity 3 plus 2t I, velocity integrated over time. So when you are integrating, you must write velocity at time t, and I want from 0 to 2 seconds by time interval. So that gives me 3t plus t square from 0 to 2 by 2I, which gives me 6 plus 4 by 2I, or 5I I can say, or I can say 5I. So you got that as average velocity. If you were to do v plus u by 2, still you will get the same answer. Suppose I change my color. U is 3I, v is 7I. U is 3I, v is 7I. And if you were to do v plus u by 2, you will get 10I by 2. That is also 5I. So with v plus u by 2, you can get average velocity, but only when acceleration is constant. Let's take another case. where acceleration is not constant. Suppose a particle is moving along x-axis. I will drop I for convenience. So particle moves along x-axis with acceleration as uh, not 3 t meter per second square. So acceleration is no more constant. Initial velocity of particle is 1 meter per second, and let us say after 3 seconds find final velocity and average velocity from 0 to 3 seconds. Suppose this is the question. Now this is not a constant acceleration, so we can't use v equal to u plus at. In fact, a equal to t meter per second square. We have to write a as dv by dt is equal to t, and when we integrate it, dv is d dt, and you integrate from 0 to t seconds and initial velocity to final velocity. So v minus u is 1, is t square by 2. So v is 1 plus t square by 2. That is the velocity at any time. Now, if you want velocity at 3 seconds, you put time 3 here. So you get velocity at t equal to 3 is 1 plus 3 square by 2. So it is 11 by 2. So it is 11 by 2. Now, let's calculate average velocity. Average velocity is velocity integrated over time by time interval. So velocity is 1 plus t square by 2. This is the correct way of calculating. So t plus t cube by 6. So 3 plus 3 cube by 6 by 3. That is 1 plus 3 square by 6. 1 plus 3 by 2. That's going to be 5 by 2 is the average velocity. But if you were to do the calculation in the wrong way, and if you say average velocity is v plus u by 2, v plus u by 2, okay, what is v here? We got it 11 by 2 plus u. What is u? 1 by 2. So it is 13 by 4. That's really wrong. It's not 5 by 2. So if you were to do v plus u by 2, you won't get average velocity. You would have got that only if acceleration was constant. So initial plus final by 2 is not average. If you want to calculate average of a quantity, you have to integrate that quantity with respect to time and divide by time interval. That's the only way. So that's what I wanted to tell you here. You can try your own examples and get to this idea. I hope you understood this. Thank you.